Hey, it's Ross from rosslukeman.com. Today I want to talk to you about one of the biggest questions that I receive on van and RV power systems, which is how can you have multiple chargers going at the same time and charging a single battery bank? Do the chargers talk to each other? Do they coordinate their charging somehow? How does all of that work? And the answer is a no, but there is kind of a caveat which I'll share with you at the end of this video. So the no answer comes from if we think of the battery. Let's say we have a single battery, we've got 3 chargers. Let's imagine that this battery is a big tire. So you've got a tire and you've got a valve stem. Typically, like on a car tire, you would have one air pump and you would connect to that valve stem and you would pump up the tire. What we can do is expand that analogy to, let's imagine there are 3 valve stems and there are 3 pumps on the tire, and they're pumping it up. We could call one pump solar, one pump alternator, and one pump shore power, and they're all pumping at the same time, and they don't necessarily know that the other pumps are there, but what they're going to do is they're going to charge up or pump up the tire to a certain cutoff pressure, and they're going to cut off. So we could say 30 psi, all of the air pumps cut off, and this could be also related to a water system in a van or RV. You've got your water pump and you turn it on, it's going to pump up to a certain pressure, and then it's got an internal pressure valve and it's going to reach that cutoff pressure and it's going to shut down. Even though the electricity is still connected, you've got your switch on, it's supposed to be on, it turns itself off when it reaches that set point pressure. And so we can take that analogy even further with these chargers. They are basically going to be programmed to a cutoff pressure. So if we take the tire analogy with air pressure and we relay that back to batteries, the pressure for batteries is voltage. So voltage is also known as electromotive force. So you think of the force part of that name. It is a measure of the force of the electrons going through a cable, or the potential force of the electrons in a battery. If we allow those electrons to flow out, the voltage of the battery is talking about the force that is able to come out of that battery and do some type of work. And so we can think of the different chargers as little air pumps. They're pumping up the battery until it gets to a certain cutoff voltage, and then they all independently shut down. And how they would relate is, let's say that the shore power charger is putting in 10 amps, and typically it might take an hour for the battery to charge up, but somehow miraculously the battery charges up in 20 minutes. And that's because there's additional amperage coming in from the other chargers. So the shore power charger is not necessarily aware of the alternator charger and the solar charger, but miraculously it gets to its set point cutoff voltage earlier, and it says, well, the battery's full, it's reached its set point voltage, I guess I better shut down. And so that's how they can all kind of operate independently of each other and not really know that the other charger is there, but still cut off at that set point. So that's when you're going to come in and do your programming. You're going to tell it, here's your set point voltage, and that's often going to come from the battery manufacturer. They're going to tell you, shut it down at 14.4 volts or charge it at 14.4 volts. And basically that is going to be the set point that the chargers use to reach that, and then they're going to throttle down when they get to that voltage. They're going to go into absorption mode, and that's where they're going to kind of draw down the current that's going into the battery. But all of this is controlled by the voltage. And going back to our tire analogy, it's like air pressure. So the pumps don't have to know that the other pumps exist. That tire just gets pumped up a little bit faster and they shut off at their set point. So that's how all the chargers can charge a single battery bank, not really knowing that the other chargers are there. Now there is a situation, especially with all of this Bluetooth nowadays. We've got Bluetooth with all of these chargers, and it talks to our phone so we can see what's going on with the charger. Inevitably though, the chargers are going to be designed where they can talk to each other. And as I said with shore power charger doesn't necessarily need to talk to solar at this point in time. They have their cutoff voltages. They're going to independently operate and cut themselves off. But the battery would kind of beg to differ. The battery has some parameters that it wants to send to the chargers. And one of those is the actual battery voltage. So especially with shore power, you're sending a lot of amps through those lines. Let's say you have an inverter charger, you can send maybe 100 amps through these big lines. Well, the higher the amperage goes, the more distorted that voltage reading gets back at the charger. Because there's friction in the lines, you have a voltage drop. So the charger, if it's sending a lot of current, it's going to take a reading and it's going to say, okay, this is the voltage of the battery right now, but it's going to be off. And with the inverter chargers, you're able to put in two little tiny wires. For the Victron inverter chargers, it's called V-Sense for voltage sense. And you can put in little 18 gauge wires that will go, and their only job is to take that voltage reading and give it back to the inverter charger so that that's accurate. And it will quit taking a voltage reading through those big lines where all that current is flowing, which is going to lead to inaccurate readings. And it's kind of also the case with the alternator and the solar chargers. They're not going to send quite as much current typically, but there's friction in those lines and that reading is a little bit off. And so the battery says, it would be great if you chargers had an accurate voltage reading of my actual voltage. And the other parameter that's critical is temperature. With lead acid batteries, the temperature is going to be, the charging is going to be temperature compensated. If we can get the battery temperature to the chargers, the voltage is going to be adjusted slightly up or down based on whether the battery is hot or cold. Now, if we go into the lithium batteries, they also have some parameters based on temperature. Now, their voltage, the charging voltage is not going to adjust based on their temperature, but they have a cold temperature at which point you don't want to charge them below that temperature. And so for different reasons, either a lead acid AGM battery or a lithium battery, it's great if you can communicate the battery temperature to those chargers to have them shut down either when it's cold for the lithium or adjust their charging voltage for the lead acid. So you don't have to retain all that. Basically, it's great if you can send the battery temperature out and the chargers can adjust themselves based on that battery temperature. And so they have the Victron Smart Battery Sense, which you can stick on the battery bank. It's going to take a temperature reading. You connect it to positive and negative. It's going to take a voltage reading, and then it's got a Bluetooth output. And some of the chargers, notably this was created for the solar chargers, it's going to send that temperature and voltage data to the solar charger so that the solar charger can adjust its charging voltage. And then in the case of lithium, let's say it gets to freezing, the charger can shut down and not charge the battery below freezing, which would damage a lithium battery. So the way that we are going to bring that in is with a smart shunt or a BMV 712. So let me grab the smart shunt. So this is the smart shunt, and it's got an input for positive battery voltage. The negative runs through the shunt, so that gives it its negative reading. So it's got positive and negative, but the smart shunt as well as the BMV 712, they have a second input where you can bring in temperature. You can bring in a couple of other parameters, but for our purposes, we're going to bring in temperature for that second input. And instead of running the positive line that comes with the smart shunt, what we can do is we use the temperature sensor. This is about $30, and it's going to connect to the positive lug of the battery, and it's going to provide a positive voltage to the smart shunt, and then we put the other wire into the temperature sensor and it's going to provide temperature. So this thing is going to pick up the current, the voltage, and the temperature going into the battery, and it's going to be able to send that wirelessly through a VE.Smart network to the solar controller. It's also going to be able to send it, recently it's now able to send it to this IP22 blue charger, which we can call shore power. At this current time, it does not send the data to the Orion smart charger, but that's likely in the works. It's listed as maybe a future potential charger. But the main thing that we want to do is we want to have that battery monitor. You want to have a battery monitor anyway, and we might as well connect the temperature sensor to it. It's going to power up the battery monitor, and it's also going to give it that temperature reading. And again, this will show up on your phone in the Victron Connect app, but it's not that useful for us. We can say, okay, it's below freezing. Hopefully the battery management system shut down or disconnected. But really, it's extra useful if this thing can communicate to the solar charger and say, you know, it's below freezing, shut down solar charging. And that's super useful. And I would advise you, if you're using the Victron components, to go ahead and set up this VE.Smart network and get these components to talk to each other. So they can talk to each other in some capacity, but it's not necessarily for the purpose that a lot of people think, which is they all have to coordinate, talk to each other and coordinate charging. They can charge simultaneously, but they really need to talk to the battery and get some of that data so that they can shut down or adjust their charging voltage in real time based on the battery's voltage and temperature. So what we're going to do is we're going to throw these into a system, and I'm just going to quickly show you how to set up a VE.Smart network. It's actually pretty simple, pretty easy to do as long as you have the right hardware. So we'll put that together here in just a second. But before we do that, if you're interested in your overall power system as we have here, solar, shore, and alternator power, I have a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of those three major charging sources, solar, shore, and alternator power. And it talks about how they all have strengths, but they also have weaknesses. But when you bring them together in a holistic power strategy, it's going to make sure that you have a good charge source no matter where you go out on the road. So wherever you're camping or staying, you're not going to have to worry about running out of power, and you can enjoy your travels out there and not worry about your electrical system. So there's a discussion of those three major charging sources. There's also a discussion of different battery chemistries and the strengths and weaknesses of each battery type, and that's going to help you narrow in on which battery type is going to be right for your situation. And then lastly, there is a really interesting diagram that basically shows everything that I have here on the table and how your three major charging sources can connect through the system, charge your batteries, and then get distributed to your end devices such as your stove or your laptop. How does that power flow through the system from, say, your solar panel to your laptop, and what are all those connections in there? So it's a really illuminating diagram that I think you'll find useful. If you want to get your own copy of the Ultimate Van Power Cheat Sheet, all you have to do is click that link below or go to rosslukman.com/vanpower. So with that, let's throw these into a system and we'll set up a VE.Smart network so they can start talking to each other. So I've got two of our chargers integrated in an overall power system here. This system was set up for my last video where I talked about how to add shore power to an existing power system. So check that out if you're interested. Now we have our solar charger and our blue smart charger, which we're calling shore power. We've left out the Orion because that currently does not connect to the VE.Smart network. So we're going to be integrating these two chargers with this battery monitor here. This is a BMV 712. And as I said, you can use this model or you can use the Smart Shunt. If you have a battery monitor, you don't need the Smart Battery Sense. So I mentioned earlier in the video, the Smart Battery Sense is going to stick to the battery. It's going to take a voltage reading and put out that Bluetooth signal. If you have a battery monitor, that device is not needed at all because the battery monitor is going to take those readings. Now I've also connected our temperature sensor to battery positive and routed it over to our battery monitor. The B1 terminal is going to take that positive battery voltage. Of course, the negative side actually runs through the battery monitor, so that's where it gets its negative. And then the temperature sensing is going to come in the second wire, the black wire, and that's going to go into the second input, the auxiliary input on the battery monitor. And then when we get into the programming, we'll select temperature as our auxiliary input. You can also do the starter battery voltage or the midpoint voltage of your battery bank. But instead of those, we're going to select temperature. I'll show you that in just a sec. And that is pretty much our setup. What I'm going to do now is bring in the Victron Connect app. I've got a little double-sided tape. We'll zoom in on the screen here and I'll show you how to set up a VE.Smart network. Now I do want to point out one thing. You are going to see it mentions synchronized charging. And this is one additional detail I want to mention. If you have multiple solar chargers, you can synchronize them. They'll talk to each other. Or if you have multiple blue chargers, this is a 30 amp. Let's say you want to do 60 amp or 90 amp. You can get chargers of the same kind to synchronize their charging cycle. So you'll see that here on the app in just a second. At this point, let's zoom in and set up our network. Here we are in the Victron Connect app. You can see we have our smart lithium battery coming in at the top. I'm going to go ahead and leave that alone, and we'll focus on these last three items, our battery monitor and our two chargers. And I will say it's a good idea to go ahead and do the general programming of these, and then we're going to come in at the end and set up our VE.Smart network. So these have already been programmed. I do want to show you on the battery monitor how we select the temperature sensor as the auxiliary input. So let's start with that. I'll click on the battery monitor. We're going to go to the gear icon, and where it says miscellaneous, this is the programming menu. Go down to miscellaneous, and you can see it says auxiliary input, and I've selected temperature. If I click on that, we can select starter battery voltage, midpoint voltage of our battery bank, or temperature. So we want to select temperature, and then I've selected Fahrenheit as my temperature unit. So that's how you would set it up for the temperature sensor. And then you can see right below miscellaneous we have the VE.Smart networking. So we'll go ahead and go into that menu, and we just hit create network. I'm going to call this my power system. Okay, and it's just going to create the network. Pretty easy, and the battery monitor is now able to transmit voltage, current, and temperature to any other devices in range. And it says in range for this device. We have nothing here now, but when we add the chargers, they'll show up here. So we'll go back out and go down the line to the first charger, the VE.Smart charger. Again, it's already been programmed to set up the VE.Smart network. We're just going to click the gear icon, go all the way down to the bottom where it says VE.Smart networking. And this time we can click join existing. We'll select my power system. And just like that, it's going to join the network, and those two devices can now talk to each other. So you can see the VE.Smart charger is using battery voltage and temperature as well as current from the battery monitor. And then it says synchronized charging. So if it does detect another VE.Smart charger on the network, it will synchronize its charging cycle with that other charger. So we need to go back out. And now we can go into the solar charger. Same deal, we're going to click the gear icon, top right corner, click on VE.Smart networking, join existing, my power system, click OK. And it's going to tell you it's using the voltage and temperature from the battery monitor, and it's also ready for synchronized charging with any other smart solar chargers it detects on the network. So pretty easy. That's how you set up a VE.Smart network. Once you have your network set up, if you'd like to disable the chargers at a low temperature cutoff, let me show you how to do that. We'll start with the VE.Smart charger, go in, we're going to click on the gear icon, and we're going to go down to where it says advanced settings. We're going to turn that on. It is going to give you a warning to be careful. We'll say OK. We'll go into advanced battery settings, and you can see temperature compensation is disabled. That is the temperature compensated charging, so we're going to leave that disabled for lithium. The low temperature cutoff, though, we're going to turn on. It's going to tell you you need a VE.Smart network with a battery monitor, for example, and we'll say OK, we have that, and then it's going to give you the temperature option. So the Victron Smart Lithium battery shut down at 41 degrees Fahrenheit, so if we had that particular battery, we could say let's shut down the charger maybe at 43, click OK, and we'll go back out to the solar. Click on the solar charger, click on the gear icon. This time we're going to go into battery. Scroll down to the bottom, you can see temperature compensation is disabled for lithium. Looks great. Low temperature cutoff, we're going to go in and turn that on. It's going to give you the same warning about a VE.Smart network. We've got it, so we're going to turn that on. We're going to bump that to 43 and click OK. So if your battery shut down at 32 Fahrenheit, maybe you shut down your charger at 35 degrees Fahrenheit, a few degrees above kind of the danger zone. But that in general is how you're going to set a low temperature cutoff so your chargers shut down before they damage your lithium battery at cold temperatures. So that's a look at the future of battery charging, the VE.Smart network, and how these devices are starting to talk to each other to fine-tune their charging. I hope that was helpful. If you want even more help on your overall power system, you got to grab a copy of the Ultimate Van Power Cheat Sheet. Just click that link below or go to rosslukman.com/vanpower. Thanks for watching, and I'll see you in the next video.